Welcome back to Let's Code. I'm Chris Biscardi, and today we're going to build a CLI in Rust using the clap crate that takes audio files and converts them to SRT files and transcripts using the Deepgram API. Now, my friend Jacob and I have been talking for a little bit about things we want to do with the videos that we ship to YouTube and other places like Rust Adventure or what have you. And one of the things that we want to make more automated or easier for ourselves is the generation of SRT files, transcripts, and other text-based captioning. So what Jacob's gone and done is used the Deepgram API and SDKs to develop a test application that successfully calls out to the API, and then we can generate an SRT and a transcript and some stuff from that. Now, Jacob got it all working. He's using a branch here called all mods in the Deepgram Rust SDK repo. So I don't know how stable this is going to be for us for a little bit, but it does work as of today. And what I've done with that is wrapped it into an actual CLI wrapper with clap and correctly configured all of the arguments to pass in, and then got it, cleaned it up a little bit, made sure all the tests were passing, things like that. So we're going to talk about building the CLI today. And the CLI is called Lamarck, which you can see on the right-hand side here. It's called Lamarck because of this crab, which was recently discovered, which is, I think, a sponge crab called Lamarckdromia beagle. I think, yeah, Lamarckdromia beagle. So this crab is super cute, and it's now the mascot of this project. We may change the name. Yeah, it's not a very recognizable name. Lamarck is also the mark in French, I think. So that's kind of cool. If you're live streaming and you make some marks on the stream for clips and stuff, this is going to be a audio visual processing toolkit for us. So I just needed a name to start the project. And on the right hand side here, you can see we've got Lamarck 0.1.0. The usage is Lamarck and then some subcommand. The only subcommand we really have right now is caption, although this is also the help output that we get from clap. So if we do caption -H, I think is the right. So if we do caption-H, we get all of the documentation. Make this a little wider, I think, for the moment anyway. We get all the documentation. You can see that Lamarck caption is a subcommand. We've got a number of options we can pass in. We've got the Deepgram API key, which can also be specified as an environment variable. And then we've got some input audio file to send up to get the SRTs back from. I hope that is not my Deepgram API key. Okay, that is actually my Deepgram API key. So we are going to have to make sure that that does not display in the help output. That is really weird that that would just display in the help output. I was not expecting that. So anyway, learned something new about clap today, I guess. -H will print the help information. -I is the path to an audio file. -O is the file path to use to write out the files. We can print the version information, and we can specify a couple of different output formats, such as SRT and transcript. These output types are all Boolean flags, so you can just specify -M or not. They're all false by default, so you have to do like -ST if you want SRTs and transcripts. And this should be the full command. So when this is a binary, this cargo run will be Lamarck, but cargo run -- allows us to pass the subcommand called caption. The file that we want, I'm going to put this in tests. So we have a tests folder in this project. I'm going to do test/testoutput.srt. We're going to do SRTs and transcripts and use this file here, which is the Vertex shaders video that I had yesterday, as the input file. And you can see here that we have a progress bar that was showing up for a little bit there. I guess it wasn't, it didn't take long enough, but this is a printout for some debug information of the full SRT. You can see that there is actually some progress that is going on here, but it only took 5 seconds. So maybe we'll chomp this down. This is a 20-minute video that it took 5 seconds on, which is kind of nice. So if we go into our project, there's a testoutput.srt here. I'm going to get rid of this. A couple of things are wrong. So like every video I say, welcome back to Let's Code, but this is Let's Go On. So there's a couple of things that I'm going to need to go through and actually fix. The text output has the same output, so I'm going to need to make the same changes here. And then I have the transcript and the SRT ready to go, and I can upload them to YouTube. So that's the CLI. That's what it does. That's the output that we get out of it. And let's go over sort of the project and how it's set up and how to build a clap CLI with multiple subcommands. So first of all, to start out, we use quite a few dependencies. This is kind of like a production thing that we were trying to use. So I've got indicative for the progress bar that we saw, the spinner. We guess the MIME type from the file. So I use MIME guess to do that functionality. MIME guess uses the path and the extensions, not the actual contents of the file. So the MIME guess could be wrong. We use time instead of chrono. For date formatting, we use Deepgram with a Git-based dependency. So this is something you can do in a cargo project. You do Git equals, and then the Git repo. And then on the right-hand side here, we've got the branch and the all mods branch. So it's the same branch that Jacob was working against for the prototype. Then we've got URL to do some URL parsing, tracing and Tokyo for async and logging things out. This error is something that we use to define errors. We use Miet for displaying errors. So if I did something wrong, something like maybe cargo run caption let's choose some directory that doesn't exist and don't give it an input file. So that will give us the clap CLI error output here. But if we can get past the clap error, we get the Miet output. So the supplied output directory doesn't exist. Create it if you wish to write files there. This is a string that I've written using this error and Miet and things like that. So the output is kind of nice. And we get to put whatever we want there and add additional context and things like that. Request is something we have that I'm realizing that I don't think we actually use suddenly. Yeah, we use the SDK for our actual request. So that's in a dependency that I should remove actually. But other than that, Saturday and Saturday JSON for serializing requests. Actually, we might use a request in one of the tests now that I think about it. Clap is doing the argument parsing for us. We use the derive and environment features because we need to derive clap because I kind of like the struct opt approach of deriving all of the functionality so that I don't have to write it. And then we also use the environment flag for that Deepgram environment variable that we saw earlier. And then Camino is used for UTF-8 path buffs. So path buffs in Rust are by default because the standard library can't really take an opinion on this because it has to be able to read really old paths or paths on systems that like don't really get used anymore. It can't restrict path like file paths to UTF-8. By using Camino, we can. So we have chosen to do that. The project is split up into a main.rs and a lib.rs. The main.rs basically just calls the functions from the lib.rs. So we'll go there first. CLI is our clap-derived struct. And then we match on CLI command. We'll look at this in a second. And we call Generatecaptions with the options that we passed in as a user, which are the flags that we saw earlier. And finally, we do into diagnostic. This returns a Miet result. And into diagnostic and whatnot gives us the fancy error output if anything goes wrong. We've used Tokyo here because the Deepgram SDK does some async stuff. So we've chosen to go async for our CLI. And then our library is called Lamarck by default. And we are importing Generatecaption CLI and commands, which is something else that we've defined from our library. So if we go into our library, we can see that we derive parser on this CLI struct. We could rename this. Doesn't really matter. But clap will include the author, the version, the about, and long about, and some other stuff if we want to. So if we do cargo run, and we run the help subcommand, or maybe it's not doing that. Maybe, oh, you know what it is? Actually, now that I think about it, it's that I didn't put the author information into the cargo toml. So there is no author information to display here. Whoops, which is fine. I'll add that in later. I'm actually going to publish this before the video goes live, so that won't be an issue. So we have a couple of attribute macros here. This is the way that everything works with clap. So the CLI allows us to define subcommands using the attribute macro and the subcommand like argument to the clap attribute macro, which is this command. So commands defines the subcommands. In this case, we have caption. We've chosen to use an enum here so that we could have additional subcommands. And I've chosen to use a separate struct inside of that enum to define all of the flags and things like that that we want, because the Generatecaptions function that we have right here will take that caption struct as an argument. So it makes it really easy for us to go from like a subcommand in main. So if we match on which subcommand was used, we get caption. And then the options here is that caption struct. If you can see that here. So it's a shared reference to the caption struct, and we just pass the caption struct in right here. Otherwise, we'd need to do a bunch of finagling right here, and that gets really annoying, as I've realized from past projects. So subcommand called caption. The caption struct is defined in the captions file. At the top of lib.rs, we have this captions module defined. And yeah, so we've got this captions module. We define the Deepgram API key as being something that we need. I've defined it as being able to be passed in from the environment or as the long name. And I've chosen to not use the short name. So a lot of these have short names like -I or -O or something like that. But I figured the Deepgram API key should be written out all the time. So I left it long. And this is the same thing that we were doing before. Basically, we're deriving args here instead of deriving parser. And that tells Clap that this is the arguments that we get from running caption like this. So if we run caption and we run help on caption, which is something we get by default with Clap, which is really nice. All of these comments that you're seeing here, the / comments, are used as documentation in the CLI automatically. So in this case, captions require a Deepgram API key. I'm just going to burn this API key after this video. I'm not even going to worry about it. The Deepgram API key, captions require a Deepgram API key. So you can see that I've written that over here. And the same thing for any of these, a path to an audio file or URL, input, a path to an audio file or URL. So getting all this documentation is really nice. The one thing that I do want to point out is this output type heading is something that I've defined. So we have SRT, transcript, and markdown a little bit later. And in addition to short, which is like -S for this, long, which is --SRT, or the default value, which in this case is false for all of them. We can also specify a help heading. And in this case, I've specified output type for each of these, which automatically groups them down here, because otherwise they'd be jumbled in with all these other options. And I wanted to make sure that they were clearly demarcated as hey, if you want an output format, you have to specify one of these flags. So that's all really nice and good. The other thing is that we've got this caption error here. I'm really not going to dive into Miet too much. Miet is conceptually simple, but hard to get your head around if you've never used it. So maybe I'll make a different video on that. But we basically got this caption error, which we're using this error to derive the standard error trait for. And then we use this error macro to define the message that gets output, like we saw earlier. The diagnostic gets a code here, which let's see if I can re-trigger that. So you can see that the supplied output there doesn't exist. That is an error that is right here. So we define the error with that text. We define the diagnostic code, and we define the, this is an enum, right at the top there. So each of these can have data inside of it, which is a feature that's fairly unique compared to other programming languages. So if you've never seen an enum before, this will look very confusing, but understand that basically caption error is a list of errors that we could have. It has to be one of them. So it's either going to be an IO error, like we failed to write to a file. Maybe we had an input parse error or a Deepgram error. So we passed through all of the errors that we could have from the Deepgram SDK. The output dir could not exist. We don't create it in this case. So we include the directory that we tried to look into as additional information in that error. And then things like mime guess and invalid mime types and things like that. So we can define all of these well. And I've chosen to do that. You could also just not do this and just pass back dyn error or whatever. But I think that for libraries, for things that I work on, I really like having well-defined errors. And then this is how we get this Deepgram errors that we'll see later into the actual caption error. So for Deepgram error, or for caption error, we implement from Deepgram error. We pass in a Deepgram error, and then we get basically the opportunity to wrap the Deepgram error in our caption error. And that is the reason that later on, we're going to see bare question marks to handle results from the Deepgram API. So specifically right here, this question mark on this Deepgram client transcription pre-recorded await call is going to be a Deepgram error if it fails. This is a Deepgram SDK function. So the from implementation we just saw is what makes this work, because this function returns a caption error if it fails. So the question mark automatically transforms that or maps over it and uses from to make it a caption error for us and wrap it correctly using this definition, which is really useful and is really wonderful because it allows us to just kind of be like, yeah, here, Deepgram errors we can wrap, IO errors we can wrap. Really great. So the generate captions function is where all the meat of kind of the CLI wrapping stuff happens. We start off with a progress bar. This is from Indicatif. I keep saying it like that because it's French, even though my French is absolutely horrible. So we set the style, elapsed, precise, spinner, and such like that. We saw those earlier, so I won't show them again. I think we could change this up a little bit, but I didn't really try that hard. I just wanted to get it to work. We set the message generating captions, at which point it goes into the rest of the CLI. So in this case, we were pulling things off of the options. The options are this caption struct. The caption struct has the input, the output, and whether it should output any of these output formats. In this case, the first thing we do is take the output path, and if it doesn't exist, we set a default. So options.output path is an option type. It's an option UTF-8 path buff. So we clone that to take ownership over it because options is a reference, and we unwrap it. If it doesn't exist, if it's none, then we use this path buff 8 or this UTF-8 path buff instead. So we always have an output file, no matter what. Then we check to see if the output dir exists. In this case, if the file name exists, we go to the parent and we check if the parent exists to check for the directory. This actually needs to be changed a little bit to do what if we only have a file name and no parent dir. That means that we are actually in the current directory. So we're currently checking for if there's a parent directory, it exists. If we specify just a directory, if that exists, but we don't check for the case where it does have a parent, but it doesn't have like any value for that parent if we only have a file name. But anyway, this detects whether the output directory that we're going to write into exists so that we can kind of early fail before we make the API request and tell the user, hey, you have to create this folder. If it doesn't exist, again, we return one of our caption errors. In this case, it's the output dir not exist error. And we sort of tell the user what directory we tried. This G right here is something worth noting, but it's not that important. It's to work around some references in the Deepgram API that we'll get into in a little bit. At its core, this code needs to detect whether the input string that the user has supplied is a URL or a file. If it's a URL, then we use our input enum, which is either a URL or a file later, and we wrap a URL source. So Deepgram supplies URL source, which is a different struct than buffer source right here. And that's why we need to wrap it in input URL, because we're returning the source here. But because URL source and buffer source are not in the same enum, they're not the same type, which means we can't return two different types from this function. It's one of a couple kind of small grievances that I have with the Rust SDK for Deepgram, but we can wrap it in our own URL type or file type, and then we just return that. So the URL is super easy. If the URL crate can parse a URL, it will, and we'll get a URL source. If it can't, then we get the URL error. We debug that out using tracing, and we check for a file path, right? The file path from a string will always succeed, as far as I know, because we can do UTF-8 path buff from a string, and from will never fail. Whereas if it was fallible, we would be able to use try from here, but it can't fail. So we just get from, which means all strings are valid path buffers, which I'm not sure is true. So I think there's going to be a panic in here if it's not UTF-8, but we're using UTF-8. If it's a file path, then we use file from Tokyo to open it. So this is an async file open. We don't necessarily need it to be async because we're not really doing a lot of other work. But this is already an async function, so we used it. And then we match on the guess for the MIME type for the file path. So we've already pulled in the file here into file. File is a, file that we turn into a buffer later. But MIME guess will take the path and it will guess the MIME type from that path and extension. And it could have multiple guesses, so we use .first to get that. Now, .first can return an option type, so it could either, not make a guess, or it could be like, hey, I don't know anything about this, in which case we return another one of our caption errors, the MIME guess error. We need the MIME type to pass into the Deepgram API, so if we don't have it, we need to ask the user to explicitly supply it. guest.type. So MIME types are something like audio/MP3, right? So type underscore gives us that first. Technically speaking, we don't need to use type here, right? So we could have type and we could call this with our hash, and that would let us use the type keyword, which in other uses, if you type, it will turn purple like this because it's a restricted keyword in Rust. And it's something we can use for other purposes. So that's why they named this function with that underscore, but they don't really need to. They could have used the R hash approach as well. If the MIME type we get isn't an audio MIME type, then we return another one of our caption errors. You can see how like defining all of the possible errors that we could return is really useful because it helps us define and keep track of all of the different places that this could actually fail. So when somebody calls this function, we can actually programmatically match on if we want to handle it, or let the user read, hey, this is exactly what happened. This is where it happened. And this is the metadata associated with that failure. Good luck. Since a human is usually running this CLI, I've chosen to just dump it out like we see on the right here. You know, we could do whatever we wanted. Otherwise, if the guest type is audio, then we set G, which is that string that we saw earlier, to the string representation of the media type. So in this case, G will be audio/MP3 or something like that. And we need to set this G here because the Deepgram SDK has decided to make MIME type a string slice in the struct definition, which is really awkward. So if I go over to the actual repo and I go to source and transcription, and I think it's in pre-recorded, not in pre-recorded, it's in audio source. If I search for buffer source, you can see here that the definition of buffer source for some reason doesn't require a reference for the actual buffer for the file contents, but does require a string slice with a reference for the MIME type. So this, in my opinion, is another one of those little grievances that I have with this API. This should just be a string, capital S string. There's no reason for this to be a reference. We can allocate like 4 bytes for this string. I'm not processing so many video or audio files, for example, that I can't allocate 4 bytes for each of them. But more to the point, that's why this needs to be a reference. And that's why we have G up here in the first place. So if we didn't have G outside of the scope of all of these matches, so outside of the scope of this match here, then it would get dropped, right? Because we've defined it right here. We're getting it from the MIME type in the MIME types. So if we toString that here, then at the end of this else, it gets dropped and it's no longer around. So we need it to stick around, which is why it's defined outside of the scope of this match. All that said, we use this buffer source. So we've either got a URL source or a buffer source at this point. Then we construct the Deepgram client with the API key. We use some of their options. In this case, we've set them all manually, but we could make these options in the CLI in the future as well. This is called the Builder API if you haven't seen it before. So it's options builder, which is a conventional name for it. And then you call .punctuate, .language, .utterances to set options kind of on an internal version of this option struct. And then you .build, and what you get back out is a fully constructed options type. So you'll see that the type for options builder is called an options builder, and the type for the resulting type is options. That's because options builder probably has optional types for all of its fields so that we can build them up incrementally with each of these function calls. So at that point, we say, hey, we're waiting for Deepgram now. We send the actual request. Again, because the source for the URL source and the browser or the buffer source are different structs and behave differently, we actually need to construct the entire Deepgram client in here because it won't let us pass in different buffers or different sources to this function based on a different code path. So we need to construct an entirely new transcription call, which is not great. We don't really need to do that in terms of Rust, but in terms of what Deepgram's SDK makes us do, yes, we do. So we send the call, we get back the data, and we say, okay, now we're processing the Deepgram request. This request is something we have to reach into to grab the transcript. If we specified options.transcript, which is one of the flags in our commands, we clone the output file and we change the extension to .text. So this is where we get this test output.txt file. We then use the Tokyo file APIs to create the new file, and we write all of the transcript to that file as bytes waiting for it. And if anything goes wrong, again, we use the question marks to get those IO errors back out. We do the exact same thing for the SRT, except the SRT uses something a little bit different. The SRT file or the output file still gets cloned. We still set the extension, which gives us the test output.srt and the test output.txt right next to each other. And then we try to create an SRT from the response. If that succeeds, then we have an SRT file, we create that file, and we put the value out into that file as bytes. And that's the entire CLI, basically. That's all of the wrapping. So the only thing left is there's this srt.rs file, which is where we've sort of stashed the Jacob's proof of concept code. So instead of having it in the way that he had it in a set of traits and structs, I've defined a single struct with a value field, and I've defined the try from implementation for SRT to get it from a response. So if we look back at what's going on here, right? When we want to write out the SRT, we try to create an SRT from the response type. And this is where we define that functionality, or how to create an SRT from a response. In this case, it's actually pretty simple. It's the response results dot utterances. So we need dot utterances to exist because it's a Deepgram API like restriction. If it doesn't exist, we use OK or to return an error with the question mark here, which also unwraps the value so we can keep chaining stuff onto it. If we do have utterances, they will be a vec, which we are going to iterate over, we'll enumerate, and then we map over to get the actual SRT format out of it. Now, the format is pretty simple in terms of formats. There's basically this index that increments. We do a seconds to timestamp and a seconds to timestamp, and then we drop in the words that we're using at that time. And then we collect it into a string, which gives us the SRT file. The seconds to timestamp function isn't super interesting. We basically use a format and some function calls that time gives us to actually get those out. So once again, the file that we get out here looks like this. It's got the index, it's got the times, and it's got the text that should show up at those times. Now the transcription isn't perfect, so I have a couple of minutes that I need to spend cleaning this up. But this is the transcript for a 20-minute video, and it took, I don't remember, 5 seconds to do from Deepgram. So like, that's really big. That's really, really great. I'm super happy about that. The rest of the SRT file is test. So we've got this 2RSRT test. We've got a bunch of sample response data that we turn into a response from the Deepgram API, which is, if I remember correctly, no, we use the response from Deepgram. Okay. So it is a Deepgram response specifically, not a request response. But we take that from the string that we've defined right here, which is a sample response. We turn it into an actual Deepgram response type using Serday.json. And then we run the same SRT try from function to get the value out and to check it against what we expect it to be. And these tests all pass. So if I run cargo test, we'll see on the right here, I almost said the left, we'll see on the right here that we've got one pass test. It's our only test. Cut us some slack. But that's it. That's the whole CLI. It's quite a bit of code because it is like an extremely real world example. It is a bunch of code that we wrote together to make the captions for our videos that we upload. And I upload a video every day right now. So having this and being able to generate captions in about 5 seconds, and then being able to spend a couple minutes going over it and being like, okay, this needs to change, that needs to change. Super useful, super, super useful. There's plenty more to do. There's plenty more features we want to add. There's more different features that we want to add as well. Some things that we do to process our videos. I think we're going to use GStreamer for those. Those tests seem to be going pretty well. And yeah, I will see you next time. If you have any questions about Clap or CLI tools or anything, leave a comment below. I do have a bunch of CLI Clap workshops coming out on Rust Adventure fairly soon. So maybe I'll do a video talking about those a little bit. They go over a little bit more of they start from more of a beginner standpoint. So this is kind of like something that's pretty advanced. I wouldn't expect somebody to just jump in and start writing this, but maybe you can, maybe you will. So if you build anything that is Clap based and this helped you, let me know. I would really love to hear about it. And I will catch you in the next video. See you next time.